Assalamualaikum and hi, this is video presentation from Group 4. My name is Anisha Ira binti Zulkarnain. So I will talk about introduction for population growth and the Newton's law of Cooling. First of all, what is population growth? Population growth is the increase in the number of individuals in a population. The rate of growth is proportional to the number of population. So formula for population growth is PT is equal to PO multiply exponent to the power of KT, which is PT is the number of population for any time, PO is the initial number of population, E is exponential, K is the proportional number for any constant, and T is the number of any time. For Newton's law of cooling, which is the meaning is the change in temperature of an object in a given environment. The law states that the rate of change in time of the temperature is proportional to the difference between the temperature of object and temperature of the environment surrounding the object. Formula for Newton's law of cooling is Tp is equal to Te plus in bracket To minus Te multiply by exponent to the power of negative Kt, which is Tt is the number of temperature for any time, Te is the environment number of temperature, To is the initial number of temperature, E is the exponential, K is the proportional number for any constant, and T from the formula is the number of any time. So thank you. That's all from me.
Okay, hi, my name is Nur Balkis. So I will explain about Phyla table question 2. So firstly, I will explain the problem format. So the question is, a population of a small city had 30,000 people in the year 2000 and has grown at a rate proportion of to its size. In the year 2005, the population was 40,000. So A. Find an expression for the number of people in the city T years after the year 2000. B. Estimate the population of the city in the year 2010. So C. Assuming the growth continues at the same rate, when will the town have 1 million people? So for the Phyla table, we have 4 things to do. First, facts. Second, ideas. Third, learning issue. Fourth, resources needed. So I will explain the facts first. So firstly, a population of a small city had 30,000 in the year 2000. Second, we want to know the population of the city in the year 2010. Third, in the year 2005, the population was 40,000. Secondly, I will explain about the ideas. First, we need to calculate the expression for the number of people after 2000 using formula P in bracket T equal P multiple E power of KT, so we can find the population correctly. Second, we must find the value of estimate the population of the using year 2000 using T equal to 10. Thirdly, we can find the value of growth when the town has 1 million people using the rule of log. Thirdly, I will explain about learning issue from the problem format. Firstly, what is the value of the people of the year city after 2000? Second, how to calculate the population of the city when T equal to 10? And thirdly, how to calculate the year when the town has 1 million people. So, fourthly, the resources needed of the Phyla table is first one, internet. Second, e-learning under bracket YouTube. That's all for me. Thank you.
Solution untuk soalan kedua. Kita perlu keluarkan info yang kita dapat, iaitu pada tahun 2000 masa T adalah kosong, population at time T adalah 300,000. pada tahun 2005, masa T akan jadi 5, iaitu jarak di antara 2005 dengan 2000. Population at time T adalah 400,000. Kita menggunakan formula population growth. Jadi, masukkan T sama dengan 0 dan population at time T adalah 300,000. Jadi, P0 akan dapat 300,000. Apabila P0 kita dah dapat, masukkan balik P0 dalam formula. PT sama dengan 300,000 E kuasa KT. Jadi, kita akan cari nilai constant K. Jadi, masukkan T sama dengan 5 dan population at time T adalah 400,000. Jadi, akan dapat 300,000 E kuasa 5K sama dengan 400,000. E kuasa 5K sama dengan 4/3, iaitu 400,000 per 300,000. Okey, kita masukkan ln untuk hapuskan E. Okey, jadi dapat 5K sama dengan ln 3/4. K akan dapat ln 3/4 per 5 dan nilai K adalah negatif 0.0575. Jadi kita dah dapat nilai P0 dan constant K. Masukkan semula dalam formula untuk ungkapkan formula baru. PT sama dengan 300,000 E kuasa negatif 0.0575T. Untuk soalan kedua, soalan minta population at time T pada tahun 2010. Jadi masa akan jadi 10, iaitu jarak di antara 2010 dengan 2000. Jadi masukkan T sama dengan 10 ke dalam formula PT sama dengan 300,000 E kuasa negatif 0.0575T. Jadi akan dapat P akan dapat 168,811 orang. Untuk soalan C, diminta kita untuk cari masa dia apabila population at time T adalah 1,000,000 orang. Jadi masukkan dalam formula E kuasa sejuta sama dengan 300,000 E kuasa negatif 0.0575T. Masukkan E kuasa negatif 0.0575T sama dengan 1,000,000 per dengan 300,000. Jadi akan dapat E negatif 0.0575T sama dengan 10/3. Masukkan ln untuk hapuskan E. Jadi akan dapat negatif 0.0575T sama dengan ln 10/3. Jadi T akan dapat sama dengan negatif 21 tahun. Jadi kita perlu tolakkan 2000 tolak dengan 21, dapat 1979 tahun dia.
Assalamualaikum and hi. My name is Nurmaisara binti Muhammad Zaidi, number matric AA200419. I will talk about fila table for question 7. The question is, suppose you cool a pot of soup in a 20 degrees Celsius room. Right, when you take the soup off the stove, you measure its temperature to be 180 degrees Celsius. After 20 minutes, the soup has cooled to 100 degrees Celsius. Suppose you can eat the soup when it is 80 degrees Celsius. How long will it take to cool to this temperature? What will be the temperature of the soup after 45 minutes? There are 4 elements in this fila table. The first one is facts. Second, ideas. Third, learning issues. And fourth, resources needed. There are 4 facts. They are: we need to cool down a pot of soup in a 20 degrees Celsius room. Second, the temperature of the soup right after we take it off the stove is 180 degrees Celsius. Third, the soup has cooled to 100 degrees Celsius after 20 minutes. And lastly, we can eat the soup once its temperature reaches 80 degrees Celsius. There are 4 ideas. The first one is, the original temperature of the soup is 180 degrees Celsius. Second, we need to find K constant using the formula of TT equal to TE plus bracket TO minus TE multiplied by E to the power of negative KT. Number 3, we need to use Newton's law to calculate and find the period of the soup to reach 80 degrees Celsius and temperature of the soup after 45 minutes. The last one is, insert the value of K constant into 2 new equations to find the period for the soup to cool down when its temperature reaches 80 degrees Celsius and the temperature of the soup after 45 minutes. There are 3 learning issues. The first one is, what is the exact time of the soup when its temperature reaches 80 degrees Celsius? The second one, how to calculate the temperature of the soup after 45 minutes. And the last one is, what formula will be used in this situation? There are two resources needed. The first one is internet and second one e-learning, which is YouTube.
Solution untuk soalan ketujuh, kita perlu keluarkan info daripada soalan iaitu temperature environment dia adalah 20 Celsius. Seterusnya, TO sama dengan 180 Celsius iaitu original temperature dia. Masa akan jadi kosong apabila masa 20 minit dan temperature dia akan jadi 100 Celsius. Dan kita perlu cari masa apabila temperature 80 Celsius dan kita perlu cari temperature apabila masa 45 minit. Dengan menggunakan formula Newton Law iaitu T sama dengan environment temperature tambah dengan original temperature tolak dengan environment temperature darab E kuasa dengan negatif KT seperti yang ditunjukkan. Okey, masukkan nilai masa T iaitu 20 minit dan temperature dia adalah 100 Celsius. Masukkan ke dalam formula dan kita dapati K adalah sama dengan 0.0347. Kita perlu ungkapkan formula baru dengan memasukkan nilai K. Jadi formula akan jadi T sama dengan TE tambah kurungan TO tolak TE kurungan E kuasa dengan negatif 0.0347T. Jadi kita menggunakan formula baru ni untuk mencari masa jika temperature adalah 80 Celsius. Masukkan nilai 80 pada equation baru kita. 80 sama dengan 20 tambah kurungan 180 tolak 20 kurungan E kuasa dengan negatif 0.0347T. Jadi, selesaikan, kita akan dapat masa T dia akan dapat 28 minit. Seterusnya, sama juga, kita perlu masukkan ke dalam formula apabila masa yang diberi adalah 45 dan temperature kita perlu cari. Jadi, masukkan nilai ke dalam formula baru yang kita dapat tadi 20 T sama dengan 20 tambah kurungan 180 tolak 20 kurungan E kuasa dengan negatif 0.0347 darab dengan 45 iaitu masa yang diberi oleh soalan tadi. Jadi kita akan dapat temperature dia adalah 53.6 Celsius.
Discussion and conclusion. Part A. Growth and population. Question 2. In the year of 2000, a population of a small city is 300,000. This means when the time t is 0, the initial number of population, PO, is 300,000. Then, the population, P, increased to 400,000 in 2005, which is T. Using the formula, P bracket T equal to PO multiplied E to the power of KT, the proportional constant K is negative 0.0575. So the expression for the number of people in the city 3 years after the year of 2000 is P bracket T equal to PO multiplied E to the power of negative 0.0575T. Next, to estimate the population of the city in year 2010, time T is equal to 10 is insert in the equation P bracket T equal to PO multiplied E to the power of negative 0.0575T. The population P in 2010 is 168,811 people. Lastly, using the same equation, P bracket T equal to PO multiplied E to the power of negative 0.0575T, when the population P is 1 million people, the time T is negative 21. This means when the population P is 1 million, the year is 21 years before the year of 2000, which means it is in the year of 1979. Part B. Newton's Law of Cooling. Question 7. The information that is given from the question is bowl of soap is supposed to be cool in the temperature of the environment, TE 20 degrees Celsius. The temperature right when the soap is taken off from the stove is 180 degrees Celsius, which is represented as the starting temperature, TO. After 20 minutes, T, the temperature is equal to 100 degrees Celsius. Using the formula, T bracket T equal to TE plus bracket TO minus TE close bracket multiply e to the power of negative KT. The proportional constant K is 0.0347. This will take time T around 28 minutes to make it cool down to the temperature 80 degrees Celsius. To calculate the temperature of the soup after 45 minutes, insert the time T equal to 45 and K equal to 0.0347 in the equation. T bracket T equal to TE plus bracket TO minus TE close bracket multiply e to the power of negative KT. The temperature T after 45 minutes is 53.6 degrees Celsius.